Hello everyone! Unlike the others, I would like to start this issue with some kind of prologue. The ideal option for analytics from the point of view of methodological approaches of classical cost engineering is the presence of either reliable or at least some kind of cost breakdown, i.e. the presence of something that can be analyzed. The trouble is that in real practice, external suppliers as a rule do not represent it, limiting themselves to providing a technical commercial proposal. As is probably already clear today, the subject of our consideration will be a criticism of classical approaches to the theoretical and practical cost engineering. The concept of classical value analysis and value design engineering and classical division of value analysis and value design engineering will be introduced below, so it makes no sense to look for them in some open or closed sources. I believe that people who are more or less related to cost engineering will not have cognitive problems when perceiving these terms. Nevertheless, in order to avoid misunderstanding, I suggest starting from the meaning of the first word in this phrase, namely from the meaning of classic, as indicative, characteristic, typical, the most common or aroused in the course of practical development and evolution. The idea of this issue arose in the context of solving a set of theoretical and practical problems, both the framework of working our practical methods of functional cost analysis and design engineering and value design engineering, and when I was a specialist in such a conditional classical cost engineering division, which will be discussed below. The issue of criticism of classical approaches to theoretical and practical cost engineering relates to Block 3, named Cost Engineering as a section of value analysis of training course Cost Engineering. The following keywords will be used as part of discussion of today's topic. I recommend the viewers of our channel familiarize themselves with these keywords before watching this video. So, at the stage of development of preliminary documentation, see GOST 2.103, we actually find ourselves in a situation where, as part of the project implementation, it becomes necessary to perform an analysis and make a manual design and engineering or manual decision under the conditions described on the slide. In this case, the main conditions for making a decision are given in the formation support of which cost engineer is involved. In issue number 3, calculation mathematical model, we will consider typical cost items of the calculation familiarized in the form of tabular model, in other words, in the form of table. It's tabular calculation of various types and degrees of abstraction from the upper level, commercial, I use commercial negotiations, to the lower level, I shop floor used in production planning. As well as the intermediate variance calculation from European, etc., that the cost engineer has to deal daily within the framework of practical activities. I do not see any point to dedicating a separate issue of tabular calculation model because, firstly, there are purely applied issue, and secondly, in open sources as well as framework of practical activities. In practical activities, a cost engineer will encounter a wide variety of tabular calculations, and one way or another will gain experience and analyzing them, and independently forming them for expert assessment of the cost of an object of analysis. As a rule, each enterprise uses a down form of cost estimation, which means such requirements, the degree of abstraction of consideration, number of analyzed cost items. For example, at some enterprises, material and production costs are considered in one line, and the sum they are decomposed into such components: name of material, rate of production workers, for social contributions, the rate of workers on changeover, depreciation rates, etc. In the case of calculating the full cost of the same way, overhead cost, general production, and general economy. Defective costs and profits can be decomposed and not decomposed. The second criterion for the difference in calculation is the inclusion, non-inclusion of one-time costs, for example, R&D, production tool, technological equipment, etc., and the cost items of company calculation. It's logical that the most convenient from the point of view of the cost engineer is option of separation, one-time costs and unit costs. However, in practice, many suppliers do not form separate calculations for one-time costs. Conditions vary between costs items per unit of production, thereby complicating the analysis of calculations, which in this case become obviously incorrect or unreliable. The use of normative planned, actual or expert cost values, standard consumption, and time spans directly depends on the information security of the analysis, i.e. the logic here is simple. If there is data on actual standards, reliable calculation from supplier, ERP system, internal shop calculations, etc., or it's possible to use product cost management software, then actual or planned values of costs, time standards, depreciation rates, wage rates, etc. are used. If none of this is available, then expert values are set based on the experience of one cost engineer and information available in open sources. The automated and non-automated calculations mentioned on the slide mean expert calculation generated either by a person of using product cost management software. The disadvantage of automated calculations or the upper and middle levels of abstraction of consideration are the lack of cause and effect relationships, for example, in the form of formulas, tabular editor, which also complicates their analysis. The academic theoretical definition of cost engineering characterizes it as a kind of value analysis as a rule without further explanation, with a smooth subsequent transition to conditional practical examples. Usually of the upper level abstraction, an attempt to use them in practice in most cases leads to set consequences, since for each of these examples there are a million clarifying questions for design engineers, purchasers, technologists, and management, i.e. from practitioners. The set consequences in particular are expressed in the fact that the classification of function proposed in the academic theory of cost engineering isn't clear to most consumers or the result of the analysis. This problem alone, in my opinion, completely negates all the advantages of the value analysis in such a private manifestation as cost engineer. Another thing is the most authors of methodological recommendations and reference books of the value analysis forget to mention that classification as well as the level of abstraction of consideration, generally speaking, is a rather flexible thing and isn't an only true one, i.e. It can be completely changed, for example, shortened or expanded depending on the purpose of the analysis. My personal experience of practical application on the value analysis shown that the context of considering technical requirements or technical assignment, an extremely simple classification of functions, including only two types of function, basic and additional, is sufficient. If necessary, it can be supplemented with the operational functions. This simple at first glance classification allows, firstly, to achieve a practical effect precisely due to its simplicity and clarity to all participants in the analysis process as well as consumers of its results, i.e. Secondly, it corresponds to the structure of designation of options, basic, additional, and operational options used in the technical assignment in accordance with GOST 15.016. If we are talking about the United System of Design Documentation as well as foreign standards, SAE, AWS, NIST, ISTM, ISO, IEC, CEN, British standards in particular, the British standards 7373 standard, which we will consider in issue number 10, analogy of the value analysis methodology and technical specification information approaches. Among other things, the classification into basic and additional options is used in marketing when forming an option list. In addition, such a classification can later be used in information of sales model, the business process or the sales process, the company or the work of managers, i.e., for example, when preparing material for buyers, guided by which they will form the optional composition of their future car, for example, and the selection process is a car dealership on the dealer's website. Thus, the simple in comparison with the academic classification set out in reference books, manuals, and scientific papers on value analysis has at least three such significant advantages due to its conditional interdisciplinary, the universal classification of functions that I use in my practice, as well as the rules for formulating functions will be discussed in issue number 7, Objective Analysis Decomposition, Formulation of Functions. The classification of functions given in issue number 7 is also not a dogma and, if necessary, can be adjusted to a specific task. However, the results of its use within the framework of the management accounting system, as well as value design engineering, i.e. design support, show its versatility and the possibility of covering a large range of analytical tasks. If used both for the above and to be part of the modified form, the classical division of cost engineering, which exists in practice in the economic or commercial services of mechanical engineering enterprises, in most cases either heard something about the value analysis in the university but doesn't use this technique in practice, or doesn't know about it at all. For my part, I would add the following comments to this definition. The classical cost engineering system, which exists in most mechanical engineering enterprises, involves analysis using data on either the actual or expert cost of the product. In particular, actual unloading from the ERP, shop calculations, etc., i.e. conditional, reliable, or confirmed calculations. Or we're talking about expert calculation, independently generated calculations and calculations received from suppliers in the appendix to the technical commercial proposal, i.e. conditionally unreliable or unconfirmed calculations or cost breakdowns. We don't touch the issue of the product cost management software in this case. We note only the obvious thing. The accuracy of the analysis results is directly proportional to the level of reliability of calculations, i.e. ideally we are dealing with the shop calculations, and further towards fall taking into account dubious invoices and profits, especially if the calculation is obtained from an external supplier and not from a conventional factory inside the perimeter of the developer company. And the worst case, we are dealing with expert calculation, i.e. the result of notorious expert assessment. From the comparative characteristics of the classical cost design engineering and cost engineering division and value analysis and value design engineering methodology shown on the slides above, we can draw a preliminary conclusion that the value analysis and value design engineering methodology, in fact, being a set of applied analysis methods, surpassed in volume the methodology of classical cost engineering, conventionally designated by us above a set of methods that are used in their practice by a typical a cost engineering division integrated into a structure of a management company or machine building enterprise or an engineering company. Of course, such superiority can be both a strong and a weak side, since in a situation it's necessary to perform a large number of standard functions, for example, analyzing calculations received from a supplier and comparing their content with normative or expert values. It's a typical task of a cost engineer. The classic cost engineering division will have an advantage in terms of work completion time, primarily due to its personal and organizational structure. Comparative characteristics of the personal and organizational structure and the effects of the introduction of a division into the organizational structure of the company corresponding to the methodology of the classical cost engineering division and the value analysis and value design engineering division considered by us will be discussed in more detail in this issue below. The purpose of forming an additional reference, design engineering documentation, which we will additionally mention in future issues, as well as in practical cases, and for which the design engineer accordingly is allocated additional time hours, is precisely the creation of such business process, in which the design engineer needs a cost engineer to perform an analysis only to verify the reference design documentation. If necessary, it's used by a cost engineer. In fact, the reference design documentation includes structural and functional models that the design engineer forms independently and places, for example, in the PDM system, as well as corresponding structural and functional model prepared by a design engineer. Reports on determining the significance, relevance, and degree of satisfaction, quality implementation, reports RQS, 6S, and their verification generated in turn cost engineer. Additionally, they included the composition of such an additional design documentation. Thus, the formation of the value analysis of value design engineering system makes it possible to form a unified system of analytical support for decision making within the framework of the project. In issue number 12, degree of satisfaction and fulfillment, quality of functions and their carriers, it will be shown that this system of analytical support for decision making indirectly also covers the marketing and quality management service. Thus, from an applied point of view, the value analysis can be considered as a tool of supporting managerial marketing and commercial decisions, and the conditions indicated on the slide. Value design engineering, in turn, from an applied point of view, can be considered as a tool for supporting design engineering and industrial design solutions, and the conditions indicated on the slide. If we specify the wording in the absence of actual communication between the design engineering or industrial design departments and the classical cost engineering departments shown on the slide, it contains a description of the phenomenon when designers or design engineers stop responding to any requests from cost engineers, even if the cost engineer is part of an engineering company. Not to mention the situation of the cost engineer belongs to another division, for example, an economic one, and in this case, the territorial allocation doesn't matter, i.e., you are located in the same city or building. Thus, the problem is more complicated. It's not only organizational, but also psychological, because design engineer, especially when he's loaded at the moment of failure, of deadlines for his main activity, includes unconditional tunnel perception to fulfill his main task, and in fact simply stop speaking on the phone, answering email, etc. Before considering the pros and cons of the classical cost engineer division and the value analysis division and value design engineer division, we concretize these concepts by outlining their organizational structure. For each of the specialists, the proposed organizational structure of the value analysis division and value design engineer division, the table contains a list of general and private job responsibilities on the basis of which a job description can be complied, as well as regulation on the division. The presented table includes the following columns and blocks. The column name of specialist, the block functions in the department consisting of column general function and private function, the column required classification, as well as the blocks of type of component object and number or quantity. I think the general overview of the table can be considered complete here. With regard to the column required qualification, it should be noted that the labor market is quite difficult to find a specialist who fully meets and above qualification requirements. Thus, compliance with this table can be achieved through additional training, additional higher education, or advanced training. With regard to the columns, type of analyzed object and columns single product and product line included in it, we know that for the classical division of cost engineering, in the case of support the development of a single product as a rule, the product is divided into systems and aggregates in accordance with the design scheme or product of the product division, and then in accordance with the complexity and skills, it's assigned to cost engineers presented for these purposes and the number of 6 people. In the case of value analysis division and value design engineer division, such a scheme is obviously not applicable since the basic cost engineer who analyzes calculations in the structure of only one, then the potential labor intensity of the work is reduced by 6 times compared to the classic cost engineer division. Thus, we come to the conclusion about the session nature of the value analysis and the value design engineer division in the case of single escort object. In the situation with multiple support objects or product line, the situation is similar. The results of the described difference in the nature of the activity in the value analysis and value design engineer division activity scheme describes and the literature in the value analysis describing the formation of an annual list of objects of analysis from 10 to 12 components, as well as implementation of field or local mini project on the value analysis, which is considered in detail, have something in common with the agile methodology. Let's consider the difference between the two types of divisions in terms of personal diversity, which is displayed in a quantity block. In particular, what is value analysis and value design engineer division is 2.5 times higher than the classical cost engineer department or division in terms of the diversity of specialists. Being equal in total number, accordingly, we gain superiority in the variety of skills that the value analysis and value design engineering division has in general. On the one hand, this is an advantage since it allows you to solve a wider range of tests. On the other hand, it complicates the process of recruiting specialists and their subsequent training. In the quantity block for the classical cost engineer division, in the line specialists in commercial information and negotiation support, the value 0 with an asterisk is indicated, meaning that specialists in areas unit systems aggregates, in addition to their main duties, can accompany commercial negotiations in their area of responsibility. Similarly, in the classical division of cost engineering, the change management procedure, supplier nomination, and other are supported. Thus, based on the result of formation of this table, we get another proof of the complementary nature of the two types of divisions under consideration, not interchangeable. Conditionally, we can say that the classical division of cost engineering carries out a significant amount of standard work with the standard requirements. For the degree of detail of analytics and value analysis and value design engineering division, selective work on the most important components with a high degree of detail of analytics achieved through the use of alternative methods, in particular information from marketing services, quality management services, more detailed analysis of design documentation, which will be considered by us in the future issues. Based on the above comparative characteristics of the methodology of the classical cost engineering division and the value analysis and value design engineering division, as well as organizational structures, the effectiveness of the two units under consideration can be calculated, i.e. the payback of their introduction into the organizational structure in the context of calculable and uncountable economic effects, belonging to which is indicated on the slide in separate columns. Typical methodology for evaluating efficiency in the case of classical cost engineering division is to estimate prices of direct costs of companies in the from was to became format, i.e., for example, from was to became before accompanying commercial negotiations and making design engineering documentation adjustments in accordance with the cost reduction action plan and after them. A distinctive feature of the value analysis and value design engineer division is the ability to evaluate the effectiveness of both calculable and uncountable methods, similar to the classical cost engineer division. See paragraphs from 1 to 5. As well as additional unique effects, see paragraph from 6 to 9, such as design support by introducing value analysis, value design engineering output data in the form of a structural and functional model into business design processes, as well as an additional design engineering documentation and references related to the 3D product layout, CAD plus PDM system. In accordance with the United System of Design Documentation, its uncountable effect, the possibility of using the output data of the value analysis and value design engineering and the framework the framework of reverse engineering, it's calculable effect, and the possibility of using the output data and the value analysis, value design engineering to form an alternative simplified form of technical assignment and technical specifications and requirements. It's a calculated effect too. As well as the possibility of evaluating indirect costs and countable evaluation method related to possibility of using the output data of the value analysis by marketing and management services. The qualities that I already mentioned above, we will talk about the issue number 12, degree of satisfaction and fulfillment, or quality of functions, or quality implementation of functions, and their carriers. Based on the results of the formation of a comparative table for evaluating the effects of the creation of classical cost engineering division and the value analysis and value design engineering division, two conclusions can be drawn. Value analysis and value design engineering division surpasses the classical cost engineering division in terms of the number of possible effects, including unique effects, see paragraph from 6 to 9, i.e. not effects that are not derived from effects similar in formulation, see paragraphs from 1 to 5, for both types of divisions. The effects are similar in formulation for both types of divisions, see paragraph from 1 to 5, are performed by different methods, classical analysis and value design engineering methods. Therefore, the value analysis and value design engineer division isn't a complete alternative to the classical cost engineer division, but is an equivalent addition that allows to increase the overall efficiency of cost engineering system in the project. It should be noted that in accordance with the proposed organizational structure as part of the value analysis division, or value design engineering division has one specialist similar in skills to 5 specialists of the classical cost engineering division. The difference, however, is that firstly his main responsibility is in the support of the value analysis and value design engineering. Secondly, even his duties are reduced exclusively to the analysis of calculations received from suppliers and the formation of expert calculations. He physically will not be able to completely cover the amount of work performed by 5 specialists of the classical division of cost engineering, which once again confirms the correctness of the assumption put forward about the complementary nature of 2 types of cost engineering divisions under consideration. So, as already mentioned above, the most common solutions to the problem of cost analysis as a part of a project to develop a mechanical engineering products is the creation of the classic cost engineer division. Let's consider the existing advantages and disadvantages. It would be logical to place the developed theoretical base as well as significant amount of methods and business processes worked on in practice. Indeed, if we start with the basic in this case and the concept of calculation, then we can see many options for a wide variety of calculation and open sources for each of the calculation articles. There is a significant amount of theoretical and practical reference information, including related regulatory documentation, applied calculations, methods, etc. With regard to business processes, the situation is similar, since the relevant publicly available as well as internal standards of enterprises, regulations, policies, etc. describe the business processes of the cost engineering division, propose standard forms for analysis and decision-making, responsibility allocation tables, and etc. In terms of versatility and interchangeability, it can be noted that the possibility of transferring various directions from one cost engineer to another Third, practice shown that any such transfer of product line or direction causes problems due to the fact that the cost engineer doesn't even have basic knowledge in the field of design and manufacturing technology of components in a new product direction if there is only the product in the project. If you're talking about the product line, cost engineer oversees the creation of several products within the same product line. For example, moves from overseeing the direction of mountain bikes to the direction of road bikes. Then, in addition to ignorance of the design, he may face such a problem in different sales and marketing models, different life cycle models, etc. The absence of cognitive problems among consumers or customers of analysis results or analytical reports mentioned on the slide is expressed in fact that most managers who, in the case of the classical division of cost engineers, are the main consumers of analysis results, have basic knowledge in the field of economics and the calculation structure. Even in general, it's clear to them. With regard to other consumers of analysis results, which in the case of design support include design engineers, in the case of commercial negotiations include buyers and suppliers, they also in most cases have sufficient qualification to understand, at least in general terms, what is at stake. The advantage of the classical cost engineering division, which consists in the relative uniformity or personal, is manifested in particular at the stage of formation of the division, as well as adjustments to its number in case of changes in the scope of work or project, as well as the case of layoffs of employees. The basic requirements for education, economic and technical work experience and work responsibilities are conditionally identical for all specialists, with the exception on the head of the department, who in addition to everything must have education and leadership experience. So the department transfers to stages of load redistribution in a lighter form. In fact, the above mentioned multifunctionality and interchangeability is a consequence of the homogeneity of the staff. The advantage of being easily integrated into the organizational structure of most machine building enterprises, I believe, doesn't require a detailed comment. As a rule, the classical cost engineer divisions is formed either as part of the headquarters divisions or directorates, or as part of the economic management of the company. Similar function divisions can be created as a part of the economic management or for production sites or engineering companies. Okay, in the context of such advantages of the classical cost engineer division as a relatively low complexity of generating initial data for analysis, we will try to form a universal list of the main information sources for the cost engineering division, i.e. a list suitable for both types of cost engineering division. Let's summarize the shortcomings of the classical cost engineering division and comment on those that are not discussed in detail above. Regarding the collision with the effect of tunnel perception and lack of motivation as a part of design and other related departments, it should be noted that engineering companies have a practice of forming such reference documentation as the preliminary design engineering documentation stage, in the form of product division schemes and the component parts by GOST 2.711. Product division schemes into the component parts, which in a compartment with designating according to GOST 2.102, they create a certain effect of design support, and are even used in the activities of procurement departments. Departments with buyers specialists. Since there's certain information about their purchased products used on their possible alternatives, however, in fact, this reference design documentation has nothing to do with the reference design documentation, which is discussed in this video. I mean reference design documentation by value analysis methodology. In addition, we know that the formal needs to create the reference design documentation at the preliminary design engineering documentation stage is clearly indicated in the GOST 2.053 standard C section 5.3, where electronic part product design structure and its abbreviation EPDS, and electronic product functional structure, abbreviation EPFS, are complete analysis of structural functional model related to the elements of the value analysis and value design engineering methodology, with the resultant possibility of forming RQS 6S diagrams and their modification based on them. Regarding the low efficiency of the analysis of calculations filled by unscrupulous suppliers, it should be emphasized that it is impossible to reliably determine the overhead costs and the profit margin of the supplier. Firstly, since this is a trade secret, and secondly, because with small production volumes, so small scale or single production, overhead costs can reach 1000 or more %. With regard to the operating with unconfirmed expert prices for materials and purchased products, we know that one of the methods to eliminate this disadvantage is to work with a fork of minimum and maximum values, i.e., in fact, the presentation of two calculation options for the lowest possible prices and the maximum possible prices. When verifying the cost of their function carrier in the value analysis, a similar technique is also often used in practice. Regarding the significant labor intensity and low efficiency of the action plan to reduce direct cost, we know that the method of factor research considered by us, that will be considered by us in issue number 9, is highly effective from the point of view of design engineering measures as a tool for analyzing cost reduction options, the disadvantage of which, however, is just the need for reliable calculations, since the statistical values of the cost reduction fork from the event are formed with the condition of having net production costs, and any addition to the overhead structure, profits, and so on leads to incorrect results or evaluating possible effects. All the above factors cause a number of disadvantages in the activities of the classical cost engineering division due to the fact that the conditional classical cost engineering, as we mentioned in issue number 1, is a type of value analysis, or rather a type of practical value analysis. Thus, the creation of a classical cost engineering division is undoubtedly a solution to a number of problems of accounting and analytical support for management. But due to the shortcomings mentioned above, it's not a panacea, and even more so the central element of the notorious set of design-to-cost techniques. The concept of the classical division of cost engineering from the point of view of value analysis and value design engineering can be presented as a practical value analysis methodology at the level of the abstraction for which the rule of principle one carrier, one function is fulfilled. A feature of such a simplified approach to analysis is need for calculations, which, as we already noted at the beginning of the video, it's not always feasible in practice. But when we talk about decision making within the framework of the value analysis division, the value design engineering division concept, i.e. decision making based on significance and importance, we're talking about a more subtle or through type of value analysis, the use of which allows you to make a decision in condition of uncertainty, including the complete absence of actual or expert calculations or cost breakdowns. The peculiarities of the application of the value analysis and value design engineering approach in this context include the need, in some cases, to confirm the cost values for the function and their carriers, determined on the basis of value of importance and satisfaction by expert calculation using real, physical and economic quantities, including mass, volume, material, production, technology, costs, and etc. Thus, a complete departure from calculations as a practice shows isn't feasible, However, the amount of work on verification using expert calculation takes up only a small part of the total amount of work of the value analysis division or value design engineer division, which is another difference from the classical cost engineering division. However, these circumstances can be attributed rather not to disadvantages, but the methods of verifying the objectively of the value analysis or value design engineering methods, the use of which can play a decisive role in the acceptance of the analysis results by individual managers, including top-level ones. That's all for today. Put likes and subscribe to the channel. Oh, bye!